You think you understand fire. You've known it since you were 3 years old. It's hot. It's bright. It burns things. End of story, except that's wrong. Not a little wrong. Fundamentally wrong? Let me ask you something simple. Not what fire does. Not what it looks like. What is fire? Is it a substance? A thing? Can you put it in a box and weigh it tomorrow the way you can a rock? No. Fire is not a thing. It is something that happens. And that realization, that tiny crack in your intuition, opens up a disturbing discovery that once you see, you cannot unsee. Visual. A log sitting in a quiet fireplace, oxygen molecules bouncing invisibly around it. Here's the puzzle. You put a log in your fireplace, it sits there. The air around it is about 21% oxygen. Oxygen molecules are slamming into the wood billions of times per second. The wood is carbon-rich. Carbon loves oxygen. When they combine, they release enormous energy. So why isn't the log already on fire? If fire were simply wood plus oxygen equals flame, every forest on Earth would be a permanent inferno. But it isn't. Why? Because nature hides a hill between what can happen and what does happen. Animation of a ball sitting behind a small ridge with a deep valley beyond. B. Imagine a ball resting on a plateau. Just ahead is a tiny ridge, barely noticeable. Beyond that ridge, a massive valley. The ball would love to roll down. There's huge potential energy waiting to be released. But it can't, not without a push. That ridge is called activation energy. At room temperature, atoms in the wood and oxygen are jiggling, but not violently enough to climb the hill. They collide and bounce apart. Nothing changes, then you strike a match. It gives the ball a shove. A tiny shove. A few carbon atoms finally make it over the hill. They snap together with oxygen, and when they do, they release energy, more than enough to push their neighbors over. And then their neighbors push theirs. And suddenly, you don't need the match anymore. That's fire. A chain reaction, a cascade, a chemical avalanche, one microscopic event triggering another, and another, until the fuel runs out. A galaxy in the sky, if the laws of presence, visual dominoes falling, but each falling dominoes explodes into light. This is the first disturbing truth. Fire is not a substance. It's a self-sustaining pattern, a process that creates the conditions for its own continuation. One whisper becomes two, becomes four, becomes chaos. But here's where it gets even stranger. Look at a candle flame. Visual slow-motion footage of a candle flame, glowing orange. That beautiful orange glow. Warm, comforting, ancient. Where does that light come from? You might say hot gas. Reasonable bikes, except a properly adjusted Bunsen burner. Hotter than a candle is almost invisible. Hotter than a candle is almost invisible. So what's glowing in the candle? Dirt. Not metaphorically, literally. When wood or wax burns, complex molecules break apart. Carbon atoms don't always find oxygen immediately. Some clump together into tiny solid particles, soot, and these particles get an IXPC. This is blackbody radiation. Heat is solid enough, and it begins to emit light. First red, then orange, then yellow, then white. Those glowing specks inside a candle flame, they are microscopic chunks of carbon heated to around 1,000 to 1,500 to 1,500 degrees Celsius, glowing like miniature suns. The warm orange light humans evolved around for hundreds of thousands of years is the glow of incomplete combustion. Perfection, complete combustion, is nearly invisible. Beauty is inefficiency made incandescent. Let that sink incandescent. Visual comparison. Blue gas flame versus orange candle versus glowing steel and forge. Now let's zoom out. You burn a log, heat and light pour out. Where was that energy before 5 inside the wood? But how did it get there to answer the wood? But how did it get there to answer that? We travel back to 1620. A man named Jan Baptista van Helmont planted a willow tree in a pot containing 200 pounds of dry soil. He weighed everything carefully. 5 years later, the tree had gained 164 pounds. The soil had barely changed. Where did the mass come from, Kaivet? Not the dirt. The air. Visual. Animation of CO2 molecules entering the leaves. Trees pull carbon dioxide from the atmosphere. They use sunlight to rip carbon away from oxygen. They build trunks, branches, roots from that carbon. Wood is made of air. And the energy required to tear carbon from oxygen, to push the ball up the hill, comes from the sun. A tree is a machine that runs on starlight. For years, sunlight pours into leaves. Chlorophyll captures photons. Energy rearranges atoms. Carbon is assembled into wood. It is an uphill battle against physics. Because here's the deeper law at work: entropy. Visual: ice cube melting in warm room. If you drop an ice cube in a warm room, it melts. It never spontaneously reforms. Why? Because there are vastly more ways for water molecules to be disordered than ordered. Nature moves toward higher probability, toward disorder. Carbon bonded to oxygen, carbon dioxide, is a lower energy, more stable, more probable arrangement than carbon locked into wood. So when a tree grows, it is doing something profoundly unnatural. It is using sunlight to push matter into a less probable state. It is climbing uphill against entropy for years. Then you light a match, and everything rushes downhill. Fire is photosynthesis running in reverse. Every bond the sun carefully assembled, flame dismantles in minutes. Fire is ungrowing. Visual time-lapse, tree growing versus tree burning mirrored. Let me give you another analogy. Imagine you spend years stacking a house of cards. Patiently, carefully. You fight gravity the entire time. Every card placed is a tiny act of defiance. Then someone flicks the bottom. The collapse is fast, effortless. Inevitable, the energy of the collapse was stored in the height. The energy of the collapse was stored in the height. The energy of fire was stored in the structure. The match is just a flick. Now here's where Feynman would lean back, grin slightly, and say something quietly unsettling. Right now, inside you, every cell in your body is performing controlled combustion. You inhale oxygen. You consume carbon-based molecules built by plants. Your mitochondria are microscopic furnaces. But they don't explode. They release energy step by step through exquisitely regulated biochemical pathways, harvesting it in small packets. You exhale carbon dioxide. Just like a flame, you radiate heat. You are a slow-burning reaction, stabilized by evolution. Have you ever noticed when you run hard, you breathe faster? Why a FIDCA? Because your muscles are burning fuel faster. Why feed? Because your muscles are burning fuel faster. They demand more oxygen to keep the reaction going. When you're out of breath, it's the same bottleneck as smothering a fire. Not enough oxygen. Biology is physics with better plumbing. Now let's step back even further. Where does the sun's energy come from? From nuclear fusion. Hydrogen atoms fusing into helium in the core of a star. Energy released because mass itself converts to energy. That energy travels 93 million miles across empty space. It strikes a leaf. It rearranges atoms. It becomes wood. It waits. It becomes coal, ove. Right 300 million years, it becomes oil. It becomes the gasoline in your car. You turn the key. Ancient sunlight explodes in controlled bursts. Thousands of times per minute. Every fire humanity has ever lit has been powered by starlight. Stored starlight. Fire does not create energy. It returns it. A fireplace is a time machine for sunlight. You are warming your hands on photons that began their journey in a star, were captured by a leaf years ago, stored in chemical bonds, and are now being released in your living room. The laws of physics say energy is conserved. Nothing is created, nothing is destroyed, only transformed. Fire is transformation made visible. But here's the disturbing part. Entropy always wins. Always. When you burn wood, the ordered structure becomes ash, gas, dispersed heat. The energy spreads out. It becomes harder to use again. The sun is slowly running down. Every flame, every breath, every prite, every breath, every heartbeat contributes to the gradual leveling out of energy differences in the universe. Life itself is a temporary rebellion. Against that leveling, we are little vortices of order sustained by constant energy flow. Like whirlpools in a river, they look stable, but they only exist because water is moving through them. Turn off the flow, and the pattern vanishes. Fire is a pattern sustained by energy flow. So are you, micro versus macro. At the microscopic level, atoms follow simple rules. Quantum mechanics, electromagnetism, probability. No intention, no purpose. At the macroscopic level, we see warmth, light, comfort, civilization. We see romance around a candle, community around a campfire, industry in a furnace. Meaning emerges from mindless collisions. That astonishing. We often imagine we live in a world of things. But physics reveals we live in a world of processes. A rock is atoms vibrating. A tree is air rearranged by sunlight. A flame is a chain reaction. You are a regulated burn. Everything stable is secretly dynamic. Everything solid is secretly motion. And everything solid is secretly motion. And everything alive is temporarily defying the most probable arrangement of matter. The laws of physics do not forbid complexity, but they demand a price. Energy must flow. Order must be paid for. Fire makes that visible. It is the bill coming due, and yet this is not tragic. Because the same laws that ensure entropy increases also allow stars to shine, leaves to grow, and consciousness to arise. If activation energy didn't exist, the world would have burned instantly. If entropy didn't exist, nothing would ever change. No life, no thinking creatures wondering about fire. The universe is not a static sculpture. It's a story of gradients, hot to cold, ordered to disordered, separated to combined. And in the middle of that story, for a brief flicker of cosmic time, matter arranges itself into beings that can understand the process. That's you. You are the universe examining its own combustion. The next time you see a candle, I want you to see more than a flame. See soot particles glowing like microscopic stars. See soot particles glowing like microscopic stars. See entropy increasing. See ancient photons finishing a journey. And see yourself in it. Because when you feel warmth on your skin, when you breathe, when your heart beats, you are participating in the same cycle. Starlight to structure, structure to flame, heat to space. Have you ever thought about how strange it is that the most ordinary things hide the deepest truths? Fire seems simple. It turned out to be a portal from chemistry to thermodynamics to astrophysics to philosophy. So here's my question for you. What other everyday thing are you absolutely certain? Why? Understand? That might, under honest examination, dissolve into something far stranger. Look at it. Really look at it, because I promise you, whatever it is, the answer will be more beautiful and more unsettling than you expect.